Hello children, you are welcome to this segment of the program The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Unkwagbaje. Today in mathematics, we'll still be working with factors, although it's going to be another aspect of it. We'll be working on prime numbers. But before we go into it, let's look at the correction to the previous homework. In the last lesson, you were asked to find the highest common factor for these sets of numbers. So we'll just go right into it. So to find the HCF of 24, 32, and 40, we just write it out like so and draw the lines. Then you see that we divide by 2, and because 2 goes in everything. 2 goes in 24 12 times, in 32 16 times, in 40 20 times. Then 2 can still go. 2 goes to 12 6 times, in 16 8 times, in 20 10 times. 2 can still go, and then we'll reduce it to 3 4 5. And then nothing can go again, so that's the lowest term. Then multiplying these 2's, we have the final answer to be 8. 2 times 2 times 2. I believe you got that one right. Let's check out the last one. The highest common factor of 48, 60, and 72 plays out like so. So we begin dividing by 2, then by 2 again, then by 3, and then that gets us to the lowest terms. Now multiplying 2 by 2 by 3, we will get 12. Now I'm sure you got all of them right. You did? Amazing you. I'm going to celebrate you with a chair. Now, moving on to that work for today. What are the learning objectives? By the end of the day, we should be able to define what prime numbers are. We should be able to say the meaning of prime numbers. We should be able to use the sieve of Eratosthenes. What is that? You'll find out. To list the prime numbers from 1 to 100. And finally, you should be able to express composite numbers as product of prime numbers. I mean, what do all these mean? Of course, you know, if you pay attention, then by the end of the lesson, this should be making sense. So, let's get right to it. So, prime numbers, what are they? Prime numbers are numbers that have only 2 factors. Prime numbers are numbers that have only 2 factors. And the factors are 1 and that number itself. I'll take that again. A prime number has only 2 factors. 1 is one of the factors. The other factor will be the number itself. So apart from 1 and itself, nothing can divide prime numbers. So they have no factor except 1 and itself. Keep that in mind as we go on this journey. Now let's look at 3 is an example of a prime number. And you immediately see that 1 can go in 3. Of course, 1 can go in every number. Of course, 3 itself is a factor of 3. But let's check. Can 2 go in 3? If we try to arrange it 2 2, we will not get a complete rectangle. So 2 is not a factor of 3. So the only factors of 3 are 1 and 3 itself. And then, which means that 3 is a prime number. It has only 2 factors, 1 and 3 itself. Okay, so 4 is not a prime number, and that is because apart from 4 and 1, 2 is also a factor. You see, we get a rectangle here. 2 is a factor. Okay, there is no remainder. So 2 can divide 4, which means that 4 is not a prime number. 1 is a factor, 4 is a factor, 2 is also a factor, and that means there are 3 factors. But the prime number must have 2 factors only, itself and 1. Let's check out 5. 5 is a prime number, and that is because there's no way you arrange it. You'll always have extra. 2 is not a factor, 3 is not a factor, only 1 and 5 are factors of 5. Apart from 1 and 5, no other factors. That means 5 is a prime number. What about 6? Let's check out 6. Of course, 6 is not a prime number because 2 can divide, 3 can also divide. So there are factors of 6. So 1, 2, 3, and 6. That one has 4 factors. So it's not a prime number. A prime number must have only 2 factors, itself and 1. Let's check out 7. So what about 7? Do you think 7 is a prime number? Of course it is a prime number. And that is because if you arrange it in 2's, you will not complete the rectangle. So 2 is not a factor. If you arrange it in 3's, it doesn't complete. If you arrange it in 4's, it doesn't complete. 4 is not a factor. So the only factors are 1 and 7 itself. And so 7 is a prime number. 2 factors, just 1 and 7. No other number can divide it. Let's check out 8. Of course, 8 is not a prime number, and that is because 2, 4, these are factors of 8. So 1, 2, 4, 8. And that has 4 factors. That means 8 is not a prime number. Do we have a way for identifying numbers that are prime? Well, thanks to this man that we call, his name is Eratosthenes of Cyrene. He was a Greek mathematician, but his name is not important. What is important is what he taught us. And he taught us a very, very intuitive way of finding out prime numbers. Okay, so let's see. Let's use what we call the sieve of Eratosthenes to find out all the prime numbers. I'm not going to do everything for you. Okay, what I'm going to do is I'm just going to show you the process, and then you take the rest as assignment. Submit the assignment, and I'll put you in contention for Good Life Magic Juice. So let's begin. This is a list of numbers from 1 to 100. So now, using the sieve of Eratosthenes, we are to cross out all the numbers that are not prime. So let me use a red pen here. Okay. All right, that's good. Now, we know that 1 is not a prime number, so we'll cross it out. We know that 2 is a prime number, so I circle it. Now, if 2 is a prime number, any other number that 2 can go in, any other number that 2 can divide, those ones will not be prime numbers. And that means 12, all these numbers here, they cannot be prime numbers. All these numbers that end with 4, they cannot be prime numbers. All these numbers that end with 6, they cannot be prime numbers. All these numbers that end with 8, 2 can go in all of them, so they cannot be prime numbers. All these numbers that end with 0, they cannot be prime numbers. Now, having removed all the numbers that 2 can go in, the number after 2 that has not been cancelled is a prime number. So 3 is a prime number, so you circle that. Then all the numbers that 3 can divide, you have to remove them. They will not be prime numbers. And that is 6, 9. So you cross out 9. And you cross out 12 is gone, 15. Then you go on like that. 18 is gone. Then you cross out 21. You cross out 27. And you continue until you get to 100. Then you pick the next number. 4 is gone, so that one is not. Then 5 will be a prime number. And that means that all the numbers that 5 can divide, they will not be prime numbers. So you cross out all these numbers that are ending with 5. And all the numbers that are ending with 0 gone. The next number that you can pick that has not been cancelled is a prime number automatically. So 7 is a prime number. Then you look at all the numbers that 7 can go in. 14 gone, 21 gone, 28 gone, 77. You cross them out until you get to the end. Then the next number, 8 is gone, 9 is gone, 10 is gone, 11 is a prime number. And then you cross out all the numbers that can be divided by 11 until there is no number to cross out. Then all the numbers that you have circled, these are the prime numbers between 1 and 100. So I want you to take this, copy 1 to 100 in your notebook, then using the sieve of Eratosthenes, cross out all the numbers that are not primes and identify all the numbers that are prime between 1 and 100. And I'll be on hand in the next lesson to show you the correct list of numbers. I have not done it. I will also do mine and show you. Okay, so let's now move on. Then we'll move on to composite numbers. What are composite numbers? Don't let the name confuse you, my friend. Any number that is not a prime number is a composite number. Again, any number that is not a prime number is a composite number. So all the numbers that we were crossing out the other time, like 9, since 9 is not a prime number, then it's a composite number. All right. So now, the thing about composite number is that we can always write them as a product of prime numbers. I'll take that again. We can write a composite number in such a way that you have to multiply only prime numbers to get it. And that's exactly the core of what we want to do today. So let's see how that is done. 36, of course, is a composite number. I mean, it has many factors. 2 is one of the factors. 3 is one of the factors. That means it is composite. Okay? So we have to express 36 as a product of prime numbers. So let's see how it's done. It's very easy, something you're familiar with. To help you, I've put a list of prime numbers there. So we'll start with the smallest one. We'll write 36 like so and draw these lines as if we want to do the highest common factor. Then we'll start dividing with the smallest prime number that can divide. So 2 is the first prime number and 2 can divide it. So 2 divides 36, you get 18. 2 can still divide. So 2 divides 18, you get 9. 2 can no longer divide, so we check out 3. Of course 3 can divide, so 3 can divide 9, you get 3, and then 3 can divide 3, you get 1. When you get to 1, that's the last bus stop. Now all you have to do is just to multiply all these, and you will discover that you will get 36. See, 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. So this is the expression of 36 as a product of prime numbers. Observe that here only prime numbers are here, just 2 and 3. But there is another way you write this. This second 2 that you see here means I'm multiplying 2 times. This second 2 that you see here means I'm multiplying 3 2 times. It's sort of a shorthand way of writing all these long things, because you can have it so long. So write it this shorthand way. 2 is occurring 2 times, so you write 2 and then you put a small 2 on top. 3 is occurring 2 times, so you put a small 2 on top of that. Let's see another one. So the next example says write 105 as a product of prime numbers. So the method is exactly the same. We write 105 like so, and draw these lines like so, as if we want to find the highest common factor, except that it's only 105 that is there. Then we start dividing with the primes, which I've put in the corner for you. You can put it in the corner of your book as well. It's not called cheating. It's just by the time you work with it for many days practice, then you will know the prime numbers in your head. So 2 cannot divide it, okay, because the number ends with 5. Okay, it's not compulsory you begin dividing by 2. It's the number that we divide that you use. So we'll start with 3 because 3 can divide, and 3 goes here 35 times. Then 3 can no longer divide, so we'll use the next number that can go, which is 5. 5 can go, so we divide 35 by 5 and you get 7. Now 7 can go in 7 because 5 cannot go in 7 without remainder. So 7 is a factor of 7 and we get 1. 7 can go in 7 one time. Then that's the last bus stop. Then we write it out like so. 105 is 3 times 5 times 7. Of course that means 3 in one place, 5 in one place, 7 in one place. Now there is a reason why I tell you to write it like this. You'll find out in our next lesson. Now it's your turn. You have to express 72 as a product of prime numbers only. Alrighty then, I believe you're done by now. Let's check out how it's done. To express 72 as a product of prime numbers, write 72 like so. Now we'll begin dividing with 2 because 2 can divide 72. Now 2 goes in 72 36 times. Then 2 can still go because this number ends with 6. 2 can go in 36 18 times. Then we can still divide out with 2 because this number ends with 8. So 2 can go in 18 9 times. But 2 can no longer go in 9. So we use the next prime number that can go, and that is 3. 3 goes in 9 3 times. Then 3 goes in 3 one time. So now in our final answer we write 72 is equal to 2 times 2 times 2 times 3 times 3. Let's just check and see that we are correct. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 24 times 3 is 72. Let's just do it again. 2 times 2 is 4. 4 times 2 is 8. 8 stops here. 3 times 3 is 9. 8 times 9 is 72. But of course the shorthand way of writing is to say that I have 2 3 times. I also have 3 2 times. And then you're still correct. Did you get it right? Good job you. But if you did not, then you have more chance to practice with the homework which is coming up right about now. You are to express the following numbers as product of primes. 1, 84. Number 2, 120. Number 3, 128. Remember, when you finish expressing, multiply back to be sure that you have gotten the right result. You have 30 seconds to copy this, but do not go away because today is Tuesday and you know what we have? Magic Tuesday. Hello children, you're welcome to this segment of the program. It is Magic Tuesday where I show you a lot of shortcuts in mathematics. Today in Magic Tuesday, what do we have? We're going to be learning how to identify numbers that are divisible by 3. Up till now, we're able to learn numbers that are divisible. We've been able to learn numbers that are divisible by 2 and by 5. But how do you know if a number is divisible by 3 without even dividing? Well, it's actually very, very easy. But before we do that, I want to ask you, check out these two numbers. Which one of them do you think is a multiple of 3? I mean, 3 can divide without remainder. Did you say the first one? Well, if you have selected the first one, then my friend, you are wrong. Because 343 divided by 3 is actually 114, remainder 1. And if you have a remainder, that means that 3 is not a factor. But actually this one is a factor. Okay, because 3 was here, you say, oh, this must be a multiple of 3. 3 should be able to go here. But that is not how to identify multiples of 3. Okay, so I'm just going to show you how to know the multiples of 3 just by looking at the number. To know the multiple of 3, all we have to do is add the digits of the number together. I'll take it again. To know the multiples of 3, we add the digits of the number together. And if your answer is a multiple of 3, then the whole number is a multiple of 3. Let's see. Look at 402 that we said the other time. Add 4 plus 0 plus 2, you get 6. And so because 3 is a factor of 6, 3 can divide 6, then 3 will divide 402. It's just as simple as that. Add the digits, whatever you get. If 3 can divide, then 3 can divide the whole number. Check out another one. This is 5,124. When we add all the digits together, 5 plus 1 is 6, 6 plus 2 is 8, 8 plus 4 is 12. Now 3 is a factor of 12, meaning that 3 can divide 12. Automatically 3 will divide 5,124. Check out this one. 343 that we said is not a factor, is not a multiple of 3. 3 cannot divide. And that is because 3 plus 4 is 7 and 7 plus 3 is 10. And 3 is not a factor of 10. And that means 3 will not be able to divide 343. So there you have it, my friend. Play around with numbers. The next time you need to divide a number by 3, do not divide and get stuck before you realize that it's not divisible by 3. Add the digits, check it first before you proceed, and that makes you a smarter mathematician. That's it for today. Till I come your way in the next lesson, remain wonderful mathematicians.